All right, ladies and gents, here is the second part of the 3134 review. We're talking about solving. So I've already put all of the worked out answers on Canvas for you guys to look at. So here's the video. And then obviously in class today, you're asking questions about things. So in number 13, I look and I say, okay, I'm starting off with e to the x. So I know at some point I'm going to have to take the natural log of both sides. So let's isolate e to the x. We're going to add 14 to both sides. Add 14 to both sides, and I get 3e to the x equals 25. Again, we want to isolate e to the x, so divide both sides by 3. So I have e to the x equals 25 over 3. And now that my function is isolated, I'm going to take the natural log of both sides. So ln of one side, ln of the other. So this cancels out. And I get x equals, make sure you put this in your calculator in parentheses, and you get about 2.1203. And that is our answer. If we want to check it, we go right back here, plug it in there, and throw it in your calculator. So now look at number 14. All right, 14, again, I'm saying this is my function. So I'm starting off with a natural log. That means I want to isolate it, get it all by itself. So we're going to add 6 to both sides. So I get the natural log of 3x equals 6. The opposite of natural log would be raising e to the x. So I'm going to say e, and then ln 3x goes up in the exponent. What you do to one side, you do to the other. So I have e to the 6th power. My e and ln cancel out. That leaves me with 3x equals about, in your calculator, 403.4288. Remember, more decimal places you have in the middle of your problem, the better. You'll get closer to your actual answer. And I'm going to divide both of those by 3. And I get x equals 134.476 about. Take that, plug it back in here, and you can check your answer. All right, when we come to 15, I have log 3x plus 1. That log is stuck in there with the 3x plus 1. So remember, this is log base 10. So the opposite of log base 10 would be exponential. So I have 10, and then I have log 10, 3x plus 1. What you do to one side, you do to the other. So I have a big 10, and then I'm going to put my exponent of 2 in the exponent. 10 log 10 cancels out. I have 3x plus 1 equals 100. And now we just solve a basic equation. Subtract 1 from both sides. I get 3x equals 99. Divide both sides by 3, and I get x equals 33. All right. Moving along here, again, we have log base 3 of 2x plus 1. My log is by itself, so the opposite of log is exponential. So I'm going to say, okay, I have 3, and then everything goes up. So log 3, 2x plus 1. What you do to one side, again, guys, you do to the other. So 3 to the 2nd power. My 3 log 3's will cancel out. 2x plus 1 equals 9. Subtract 1 from both sides. 2x equals 8. Divide both sides by 2, and you get x equals 4. Main thing to do, guys, as you're going through this is to identify what you're starting off with, what function you're starting off with, and then you can figure out what you're going to have to do as an inverse to isolate and then undo. So I look here, and I have two natural logs together on one side. I can't add one to the other side and stuff like that. So when you have two of the same log or natural log on the same side, the first thing you want to do is condense it. So I can rewrite this as the natural log of, when I see subtraction, when I condense, that becomes division. So natural log of x divided by 3 equals 4. Now I know that the opposite of natural log is e to the x, so I say e, and then I have ln x divided by 3 equals e to the 4th power. What you do to one side, you do to the other. So our e and ln cancel out. We have x divided by 3 equals about 54.598. Multiply both sides by 3. And I get x equals about 163.794. Again, check your answer. You cannot take the log or the natural log of a negative number. So make sure if you plug this back into x, this isn't negative, and you're good to go. All right, same thing here. I have log base 5 x minus 10. My log base 5 is by itself, so we can go ahead and just start undoing. So the opposite of log base 5 would be 5 exponential. So it's going to be log 5 x minus 10. And what you do to one side, you do to the other. So a big base of 5 squared. 5 log 5 cancels out. You have x minus 10 equals 25. Add 10 to both sides. And x equals 35. Now again, you're talking about logs and natural logs, so take this, make sure if I plug 35 in here, 35 minus 10 is 25. It's positive, we're good. Okay, here we have the natural log 2, natural log 3x equals 4. There's a couple ways you can look at this. You can say I want to isolate here. I want to isolate my natural log. You can also move the 2 to the back if you want to begin with, whatever works for you guys. But the first thing I'm going to do is if I isolate my natural log of 3x, I'm going to divide both sides by 2. So I get the natural log of 3x equals 2. Now the opposite of natural log is going to be e. So I have e, and I'm going to raise that to the ln 3x power equals e to the second power. My e and ln cancel out, so I have 3x equals e to the second power is about 7.389. Then I just divide both sides by 3, and I get x is about 2.463. And again, since we're talking about logs and natural logs in our original, I got to go back, and if I plug that in, make sure it does not become a negative number. So if I look here at 20, guys, I have an exponential, 3 to the x. What's the opposite of exponential? The log. So I'm going to take the log little 3 of 3x, take the log of one side, I'm going to do the exact same thing on the other. So I take log base 3 of 500. All right, guys, 3 log 3 cancels out on this side, so you have x equals, in your calculator, you would say log 500 divided by log 3. And we get that x is about 5.657. All right, so we come to this problem where it says 5 to the x plus 2 equals 4. So the opposite of our exponential is going to be log. So I'll take log base 5, and then I have 5x plus to the x plus 2 equals log base 5, 4. Log 5 cancels out. You have x plus 2 equals, in your calculator, you guys would say log 4 divided by log 5, which will give you about 0.8614. So I have x plus 2 equals that. We're going to subtract 2 from both sides, and we'll get x equals about negative 1.139. And again, you can take this answer, plug it right back in there, and you should get something really close to 4 when you check your answer. Moving along to number 22. Again, guys, this is an exponential. So we're going to do the opposite. I'm going to take log little 8, 8 to the x, equals log 8 of 1,000. So log 8 cancels out. You have x equals, in your calculator, you would do log of 1,000 divided by log 8. And you get x equals about 3.322. Plug it back in, check your answer. When you come to these next two guys, these are just quadratics. This is the same as saying 2x squared minus 5x minus 3. What you have here is e to the x times e to the x, right? If we had the same bases we're multiplying, we'd keep the bases the same, and we'd add the exponents, and we'd get 2x. So that's where this comes from. So you're going to just separate into your two parentheses. E to the x is going to go in the front of each of them. And then we factor like normal. A times c, 2 times negative 3 is negative 6. What are the factors of negative 6 that multiply to give me negative 6, but add to give me negative 5? So it'd be negative 6 and a positive 1. And again, y'all, my a term is not 1. It's 2. So I'm going to put 2 underneath both of these. See if they simplify nice and pretty. So I have e to the x minus 3 equals 0. This does not simplify nice and pretty, so this just becomes 2e to the x plus 1 equals 0. So now we have e to the x, we have to isolate it, so I'm going to add 3 to both sides. I get e to the x equals 3. Here I'm going to subtract 1, so I get negative 1, and then divide it by 2, I get e to the x equals negative 1/2. Now the opposite of e to the x is ln, so if I take the natural log of one side, I take it of the other. So here I get x equals about 1.099. Over here, I'm going to take the natural log of one side and of the other. I get x equals. If you take the natural log of a negative number in your calculator, it'll tell you error, which means that that one doesn't work. So you only have one solution here, and you can plug it back in everywhere you see an x and check your answer. Same thing here, it's another quadratic. So I have e to the x equals 0. 6 times negative 10 is 60, negative 60. Factors of negative 60 that'll multiply to give us negative 60, but add to give us a negative 11 would be minus 15 and plus 4. My a term is not 1, so I'm going to put it underneath here. Now, neither of these simplify completely into a whole number, but we can simplify. If I divide top and bottom here by 3, I get 5/2. And here in the second one, 4/6, if I divide both by 2, I get 2/3. So my denominators become coefficients. I have 2e to the x minus 5 equals 0. I have 3e to the x plus 2 equals 0. When we solve, I'm going to add 5 to both sides and then divide by 2. So I get e to the x equals positive 5/2. Here, I'm going to subtract 2 and divide by 3. So I get e to the x equals negative 2/3. Opposite of e to the x would be natural log. So I take the natural log of both sides here. I get x equals, the natural log of 5/2 is about 0.916. And then here, natural log of both sides. When I take the natural log of a negative number, I get an error message in my calculator because you can't do that. So this one doesn't work. So you have one solution. That again, plug back in, make sure it works. In number 25, I'm starting off with e to the x, so I know that I need to get that by itself, and I'm eventually going to have to take the natural log of both sides. So the first thing I'm going to do is divide both sides by 2 to get my e all by itself. Now, you guys, in your calculators, you can leave this as 45/2. You can make it into a decimal if you want, whatever works for you. But I have e isolated, so I'm now going to take the natural log of both sides. Natural log of e cancels out, so I have 0.5x equals. When you do this in your calculator, make sure your 45/2 is in parentheses. But you get about 3.114 when we take the natural log of that. Divide both sides by 0.5, and I get x equals about 6.227. Plug it back in, make sure it works. When I come to this case, I see that I have log base 7 on both sides. But in order for us to be able to use the one-to-one property and cross off on both sides, it only has to be one log on one side and one on the other. So I'm going to condense these two. They both have the same log base, so it's log base 7. Since this is addition, when we condense, it becomes multiplication. So 3 times x is going to give me 3x equals log base 7 of 32. Since I now have the same log on both sides, I can just cross it out and solve. So 3x equals 32. Divide both sides by 3, and you get x equals 32/3. Leave it as a fraction, change it to a decimal, whichever you would like. Just make sure if you plug it back in where x is that you don't have a log of a negative number. Okay, here I'm starting off with exponential. Here's my exponential. I have to get that all by itself. So I'm going to divide both sides by 12. I have 1 minus 4 to the x equals, I'm going to simplify 18/12 to 3/2. So now I'm going to say, okay, subtract 1 from both sides. So I get negative 4 to the x equals 1/2. Divide by negative 1. Divide by negative 1, and I get 4 to the x equals negative 1/2. All right, the opposite of exponential is log. So if I take log base 4 of this side, because 4 is my base of my exponential, I'm going to take log base 4 of this side. Some of you might see right here that I'm taking the log of a negative number. If you try and put this in your calculator, it will tell you error. So your answer here would be no solution. And that's okay. If you get no solution, that is okay. Because remember, you cannot take the log of a negative number. Okay, moving along to 28. I have log base 2, and then nothing. So let's condense these. Let's bring them together. So I'm going to rewrite this as log base 2. Since I'm subtracting them, when we condense, that becomes division. So I have x plus 5 divided by x minus 2 equals 3. The opposite of log would be exponential. So I'm going to say 2, and then everything upstairs. X plus 5 over x minus 2 equals 2, and then I put my 3 up as a third power. So this cancels out, and I'm left with x plus 5 over x minus 2 equals 8, or 8 over 1, however you want to look at it. Now we just multiply both sides by x minus 2 to get this to cross out. So I have x plus 5 equals, if I distribute, I have 8x minus 16. Now let's just simplify, solve this equation for x. I'm going to subtract x from both sides. So 5 equals 7x minus 16. Add 16 to both sides. 21 equals 7x. Divide by 7. And x equals 3. Make sure, since we're talking about logs, if I plug 3 in here, 3 minus 2 is 1, not negative, good. If I plug 3 in here, 3 plus 5 is 8, not negative, so we're good to go. Right here, I have my natural log 2x plus 3. I want to get that isolated, so I'm going to first divide both sides by 4. So I have the natural log of 2x plus 3 equals 11 over 4. If you'd like to compute that to a decimal, you can, or you could just leave it. If I'm going to do the inverse of natural log, I know that's going to be e to the x. So I say e, and then everything goes upstairs into the exponent. Well, what you do to one side, you do to the other. So a big E, and then 11 over 4. If you guys choose to keep it as 11 over 4, make sure when you raise e to the 11 over 4 power, you put it in parentheses. So this will cancel out. You have 2x plus 3 equals e to the 11 fourths power is 15.642. And then you just go back to solving a basic equation. We're going to subtract 3 from both sides. So I get 2x equals 12.642. I'm going to divide both sides by 2, and I get x equals 6.321. Again, we can take that, and let's make sure if I plug that in right here, it does not make my parenthesis negative, so we're good to go. All right, in this problem here, I have all log base 10, but I want to have one log on one side and one on the other, so I'm going to condense. I'm going to rewrite this as log. Since this is division, it's going to become, since it's subtraction, it's going to become division. So I say x divided by 6 equals, I'm going to move this 2 back as an exponent since we're condensing, and I have log 4 squared. Since I have one log on one side, one on the other, I can cross them out, and I just solve. X over 6 equals 16 times both sides by 6, and x equals 96. Plug back in, make sure it doesn't become negative. You guys are good. All right, there's a couple ways to look at this one. I did it one way on the review. I might do it another way here. But I see my log base 2 of x. I want to get that all by itself. So the first thing I'm going to do is minus 5 from both sides. So I have 1/3 log base 2 of x equals 2. Again, we want log base 2 of x to be by itself, so I can multiply both sides by 3. So now I have log base 2 of x equals 2 times 3 is 6. The opposite of log, guys, is exponential, so you have a big 2 since my little log is 2, and then everything goes in the exponent. And what you do to one side of the equation, you do to the other. So excuse me, so you have 2 to the 6th power. My 2 log 2 cancels out, and I get x equals 64. Plug it back in here, make sure it's not negative, you're good. On the review, I did it a little different, same answer, just because I wanted you guys to see that you can work it out a couple different ways. In this case here, we want log 5 by itself, so I'm going to divide both sides by 4. So I have log base 5, x plus 1 equals 1.2. The opposite of log would be exponential, so I'm going to say 5 to the log 5 x plus 1 equals 5 to the 1.2 power. This crosses off. You get x plus 1 equals 5 to the 1.2 power is 6.898. I'm going to subtract 1 from both sides, and I get x is approximately 5.898. And again, plug it in. Make sure it does not make your log negative, and you guys are good. Okay, moving along here. Again, we have two of the same logs on one side. Let's condense it. Let's move back together. So I can rewrite this as log base 2. Since this is addition, when we condense, it becomes multiplication. So 3 times x is 3x equals 3. The opposite of log is exponential. So I'm going to use the little log number as my exponential base. So 2 log 2, 3x equals 2 to the third power. 2 log 2 cancels. You have 3x equals 8. Divide both sides by 3. And x equals, you can leave it as 8/3. You can put 2.667, whichever you're more comfortable with. But again, just make sure that when you plug it back into the log, it does not make it negative. And our last problem. Again, we have two of the same logs on the same side, so let's condense them. I'm going to take this 2 and move it back here. So I'm going to say log base 4 of x squared. Since this is subtraction, I'm going to make it division when I condense. So x minus 1 equals 1. The opposite of log is exponential. So I'm going to say big base 4 because I want this to cancel out. Everything goes up in the exponent. X squared over x minus 1 equals big base of 4. 1 goes to the exponent. This cancels out. You have x squared over x minus 1 equals 4 to the first power. You can write this as 4 over 1. If I multiply both sides by x minus 1, those cancel out. I get x squared equals, distribute, 4x minus 4. This is just a quadratic. Let's move everything over to one side. So we have x squared, positive 4x when it moves over becomes negative 4x. Negative 4 when it moves over becomes positive, equals 0. Factor this. What times what gives me a negative 4 when I add or subtract, but a positive 4 when I multiply? That would be negative 2, negative 2. So you can just write your answer as x equals positive 2. If you write it twice, it's okay. You don't have to. But again, go back up here, check to make sure if I plug it in there, or if I plug it in here, neither of those become negative, and they don't. All right, one last thing I want to bring to your attention. Everyone's version will have something that looks like this, like log base 4 of 2x plus 7, f of x equals. It's going to ask for the domain, the range, your vertical asymptote, and the x-intercept. So remember, guys, when you're talking about logs, your range is always going to be negative infinity to positive infinity. To find the domain and as well the vertical asymptote, you set the parenthesis equal to 0, so 2x plus 7 equals 0. I'm going to subtract 7 from both sides. 2x equals negative 7. Divide both sides by 2, and x equals negative 7 over 2. So that is your vertical asymptote. X equals negative 7 over 2. Make sure you have x equals. Our domain then would be from negative 7/2 to infinity. And then to find the x-intercept, we would plug in 0 for y. And we already know how to do this. We would say log 4 of 2x plus 7 equals 0. Well, opposite of log would be exponential. So 4, and everything goes up into the exponent. 2x plus 7 equals 4 to the 0 power. So 4 log 4 cancels out. 2x plus 7 equals 1. Subtract 7 from both sides. You get 2x equals negative 6. Divide by 2, and x equals negative 3. So your ordered pair, your x-intercept would be negative 3, 0. So everybody's version, this will be the last question on all the versions. It's only going to be worth a couple points, but we just wanted to review that to make sure you guys understood. So this is the second part of your test review. Your test is tomorrow. Make sure you sign into class a little bit early so you can have the full time to take your test and that your workspace is nice and clear. All right, I'll see you guys later.